In industrial environments, keeping equipment running safely and reliably is always a challenge. Small issues like temperature changes, vibration, or power fluctuations can turn into major problems if they aren't caught early. That's where factory automation and IIoT monitoring come into play. So in this video, we're going to be walking through 4 different real-world case studies where ICP-DOS solutions were used to solve practical monitoring and maintenance challenges. These examples focus on factory automation and IIoT applications, and we'll be looking at how different ICP-DOS products were used to collect data, monitor equipment status, and improve overall system reliability. Cooling towers play a critical role in industrial production by dissipating heat generated during the manufacturing process. They use water and cooling fans to carry heat away from the system, releasing hot air upward into the atmosphere so operating temperatures can be reduced. This type of cooling system is commonly used not only in chemical plants, but also in refineries, thermal power plants, and nuclear power plants. Now in this case, the customer was a chemical plant engaged in the manufacturing, processing, and handling of chemicals. The facility operated equipment such as boilers, distillation columns, reactors, and cooling towers to produce high value added products. The customer wanted to build a monitoring system to ensure the cooling towers could operate smoothly and safely at all times. So to address this requirement, ICP-DOS provided an integrated solution that combined data acquisition, signal conversion, and communication. The goal was to enable data collection, real-time performance analysis of the cooling tower, fault diagnosis of the fan drive system, and early identification of potential damage within the cooling system. The system architecture was divided into 2 main sections. The first section focused on collecting analog data from various sensors, including pressure sensors, thermometers, and current sensors. The second section focused on vibration monitoring for the cooling fans. For analog data collection, the customer used ICP-DOS i8700 series I/O modules together with the ET87PA MTCP Ethernet I/O expansion unit. These modules were used to collect data such as hot water temperature, cold water temperature, wet bulb temperature, outlet pressure, liquid level, and the motor current of the cooling fan. Specifically, the i87017ZWG analog input module was used to collect outlet pressure, liquid level, and cooling fan motor current data. This module provides either 10 differential input channels or 20 single-ended input channels with 16-bit resolution. Each channel can be individually configured for voltage or current input. Temperature data, including wet bulb temperature and water temperature, was collected using the i87015PWG RTD input module. This module provides 7 RTD input channels and supports 3-wire RTD lead resistance elimination, ensuring accurate temperature measurements regardless of cable length. By comparing the outlet water temperature with the cooling tower's wet bulb temperature, the cooling performance of the system could be evaluated in real time. And all of these I/O modules were installed in the ET87PA MTCP Ethernet I/O expansion unit. This unit provides 8 I/O slots and supports Modbus TCP communication, making it suitable for industrial monitoring applications. It also features 2 Ethernet ports for daisy chain connections, allowing multiple units to be connected together. In addition, it supports Modbus RTU and Modbus ASC-II communication, and includes a gateway function for converting Modbus TCP to Modbus RTU. The second part of the system focused on vibration monitoring. The customer used the ICP-DOS AR400 PoE Ethernet high-speed data acquisition module so that they could collect vibration data from the cooling fan system's gearbox and motor. The vibration signals were collected using IEPE accelerometers. The AR400 provides 4 analog input channels and supports simultaneous multi-channel data acquisition. Each channel supports sampling rates up to 128 kHz. It also supports both software-triggered and analog input threshold-triggered data acquisition modes. In software trigger mode, data can be collected continuously or for a defined number of samples. In analog threshold trigger mode, data collection begins automatically when the input signal exceeds or falls below a preset voltage level. The system was designed to be flexible, allowing the customer to select IEPE accelerometers from other manufacturers as long as they meet the required specifications. This ensured compatibility while giving the customer freedom in sensor selection. To transmit data back to the control room, the system used the ICP-DOS GRP 540M 4GE Ethernet serial and CAN to 4G gateway. This gateway converted wired Ethernet, RS-232, RS-485, and CAN communications into 4G wireless transmission. It also includes GPS functionality, which can be used for location tracking in mobile applications. In this case, the gateway transmitted data from the analog input modules, RTD modules, and the AR400 back to the control room for centralized data analysis and management. With this intelligent cooling tower monitoring solution, the customer was able to collect and transmit real-time data to the control center, enabling remote monitoring and fast responses to abnormal conditions. This minimized downtime and allowed management teams to analyze trends and plan preventive maintenance more effectively, improving overall operational efficiency. Now, the second case study focuses on advanced vibration monitoring of process equipment in a steel plant. Steel plants rely on a wide range of complex equipment for raw material transportation, steel making, and hot and cold rolling processes. If a motor fails during production, it can bring the entire production line to a halt, resulting in scrapped products, reduced productivity, increased costs, and potential safety hazards. In order to reduce these risks, the customer wanted to proactively monitor bearing vibration and perform early maintenance to ensure production line safety and minimize losses. So in this solution, ICP-DOS provided an equipment vibration monitoring and predictive maintenance system. The system used an AR series accelerometer data logger to record vibration signals and calculate vibration characteristics. Vibration thresholds were set based on operating conditions, and the data was displayed in real time using a VPD series touch HMI via Modbus TCP communication. The vibration data was transmitted through an ET7000 series Ethernet IO module and then forwarded to the PLC. This approach allowed traditional PLC systems to be upgraded so that they can monitor vibration through standard current signals. IEPE accelerometers were used to measure vibration with a measurement range of -80G to +80G and a frequency response from 0.5 Hz to 15 kHz. In this case, ISN 701F15L030 IEPE accelerometers were installed on both ends of motor bearings. The vibration signals were collected by the AR400 accelerometer data logger, which provides 4 analog input channels and 1 digital input channel. Each analog input channel supports a maximum sampling rate of 125 kHz. All captured vibration signals were stored on a built-in micro SD card for offline vibration analysis. The AR400 calculated vibration features such as peak-to-peak acceleration and RMS velocity, and both of these values were compared against predefined thresholds. The VPD series touch HMI was installed outside the control panel to display real-time vibration data. The HMI features an IP65 rated enclosure for harsh industrial environments and includes a rubber keypad that can be operated while wearing gloves. It supports Modbus TCP and RTU communication and provides built-in Ethernet and serial interfaces. If abnormal vibration was detected, the VPD HMI sent a signal through the ET7224 Ethernet IO module to trigger an ALM series MP3 alert module. The ALM04 MRTU alert module provides 4 isolated digital input channels, 1 relay output, an MP3 audio output, and multiple alarm modes. It also includes a micro SD card for storing pre-recorded audio files. The ET7224 Ethernet IO module also converted vibration data into 4 to 20 milliamp output signals, allowing the PLC to monitor vibration conditions in real time. This module provides 4 analog output channels, 5 digital input and output channels, and dual Ethernet ports for daisy chain configurations. By capturing vibration signals, calculating vibration characteristics, and transmitting process data to controllers and HMIs, this system enabled real-time monitoring without overloading the PLC. The result was earlier fault detection, reduced downtime, and more efficient system operation through predictive maintenance. Now, the third case study focuses on preventive maintenance and energy management for air compressors. In this case, regulatory requirements required high-power electricity users to implement energy-saving measures, monitor factory power usage, and upload data for compliance. Previously, the customer relied on manual power recording, which often led to errors and made power management difficult. At the same time, air compressor maintenance was performed without accurate insight into operating conditions, resulting in premature or delayed delayed maintenance. To solve this, ICP-DOS provided an integrated solution combining machine status monitoring with power consumption monitoring. For machine status monitoring, the system used the PMC5231M4GE power meter concentrator to retrieve air compressor status data from the PLC. Logical controls were applied to set warning thresholds for compressor start and stop status, operating hours, oil replacement internals, and alarm conditions. When thresholds were reached, the PMC automatically sent notifications through messaging applications to maintenance personnel. For power consumption monitoring, the PMC5231M4GE collected cumulative airflow data from flow meters and power usage data from PM31333 three-phase smart power meters. By combining these values, the system calculated energy efficiency based on how much electricity was required to produce 1 cubic meter of compressed air. This efficiency data was delivered to the customer on a regular basis for review. All data was integrated into the ICP-DOS IoT Star IIoT cloud management software, which provided centralized dashboards, real-time monitoring, historical data analysis, and automated reporting. Reports could be viewed online or exported as Excel files. The PMC power meter concentrator also provided if-then-else logic functions, allowing it to trigger related equipment during emergency situations and send real-time notifications via messaging or email. So by implementing this solution, the customer reduced energy waste, improved air compressor efficiency by approximately 15%, minimized unexpected downtime, and ensured compliance with energy regulations. Now the final case study focuses on temperature monitoring in factories. Electrical control cabinet fires have become more common in recent years, posing serious risks to personnel safety and production continuity. The customer wanted a reliable system to monitor control cabinets, production lines, and warehouses in order to prevent accidents before they occur. The solution combined temperature, vibration, power consumption, and environmental monitoring into a comprehensive safety system. When abnormal conditions were detected, notifications were sent immediately to relevant personnel. At the same time, ICANN series LED displays were used to show critical data on the factory floor. For production line monitoring, the system used the ISN 811C MTCP infrared temperature sensing module in order to monitor equipment and control cabinet temperatures, along with real-time images. Vibration data was collected using the AR300T accelerometer data logger, and power consumption was measured using the PM2133D MTCP power meter. All data was transmitted to the WISE 5231M4GE edge controller, which handled logic processing and notifications. For supply chain and warehouse monitoring, the ISN 812MRTU infrared temperature sensing module monitored conveyor and storage temperatures. ALM series alarm sirens were installed to provide sound and light alerts during emergencies. All collected data was aggregated using the MDC714i Modbus data concentrator, and it was transmitted to the monitoring system over Ethernet for further analysis. The AR300T accelerometer data logger provides 3 IEPE input channels and 1 thermistor input channel, allowing both vibration and temperature monitoring. All collected data is stored on a built-in microSD card for offline analysis. The ISN 800 series infrared temperature sensors use non-contact thermal imaging technology in order to monitor temperatures inside control cabinets, reducing inspection time and the risk of unexpected shutdowns. The ISN 811C MTCP supports Modbus TCP, MQTT, and RESTful communication, and it also includes a built-in camera for visual confirmation of abnormal conditions. The Y series edge controller provides a web-based interface that allows configuration without programming. Its if-then-else logic enables immediate responses to emergencies, even if the system is not connected to a central monitoring platform. Built-in data logging ensures no data is lost during network outages, and the controller supports multiple cloud platforms. The MDC700 series Modbus data concentrator connects RS-232 and RS-485 devices to Ethernet, consolidating data into a continuous address format so multiple devices can be managed efficiently. So across all 4 case studies, the same pattern emerges. Real-time data collection, intelligent processing, and reliable communication allow problems to be detected early, maintenance to be planned proactively, and systems to operate more safely and efficiently. These case studies demonstrate how ICP-DOS solutions can be applied to real industrial automation and IIoT challenges. With a comprehensive product lineup covering sensors, I/O modules, communication devices, controllers, and management software, ICP USA provides complete solutions for a wide range of industrial applications. So if you need help on your next integration project, don't hesitate to reach out. You can contact us directly at sales@icp-usa.com, and immediately you'll start receiving assistance on your next project. Alternatively, you can also head straight to our website at icp-usa.com. Thank you so much for watching this video, and if you enjoyed it, please make sure that you hit that like button and subscribe. Thank you so much for watching.